We're going to take a look at a new equation of a line called point-slope form. And here it is over here, which looks a little clunky, but we're going to get over that. Before we get going on that, though, I'm going to remind you of another form that you just learned, the slope-intercept form, y equals mx plus b. And to make this work, you have to have a slope and you have to have a y-intercept. You must have these two or that thing's not going to work. Here's point-slope form, the new one you're going to learn today. And even though this looks clunky, there's an advantage. You need the slope, there it is, but you also can use any point on that line, which is helpful because here you have to have the y-intercept, a very specific point. Here you can use any point on that line, which is nice. So realizing that we can use any point on that line is going to be helpful because in this very first example, we're going to write the equation of that red line, but notice we don't know exactly what that y-intercept is. We could take a good guess, maybe it's 2.5, but I can't be positive. But I can be positive of these two lines. So anytime I'm going to use either equation of a line, I want to first of all write down the equation of the line itself. And as I do this, you'll notice that there's two x's and two y's, and you probably don't like that, but we're going to fix that. And you also should write down what you need, which is a slope, and you also need a point. Well, remember it says any point at all, so I can use any point on that line. So one person might choose a different point than the other person. Their work might look a little different, but in the end, they'll both have the correct answer. I'm going to choose this point, but you could have chosen that one or any other one. Now I need a slope, and I can count this slope. This line, as I go from left to right, is heading downhill, so I know my slope is going to have a negative sign. If I start here, I do a rise of -1, and then I go right 4, so -1, +4. Or if I start here, I do a rise of +1 and left 4, so +1, -4. No matter which way you go, you're having a positive divided by a negative or a negative divided by a positive, you get a negative slope. As soon as you have this information, now it's as simple as putting it into there, but because there's two y's and two x's, it sometimes is annoying, you're going to end up substituting into those three locations, the second y, the second x, and the slope. You may want to take a moment to remind yourself what's the x value and what's the y value. So here we go, y minus the y value, -1/4 x minus the x value. And it's as simple as that. I now have the equation of that line in point-slope form. All right, let's move on to this problem. We're given this equation and we want to go ahead and graph it. Well, I'm going to write right above it the equation in point-slope, or the point-slope equation. And that's going to help me concentrate on three different things: the slope and the point. Now remember, I want to graph this, and I know the slope for sure is 2/3. That's pretty easy. But the point is a little bit of a different story. It's kind of tough. At first, and this is going to be wrong, at first you think, hey, I think that point is -3, 5. That's going to end up being wrong. Oh wait, actually, I think I goofed up there showing you the wrong one. Hold on. Okay, I went to whiteout and made some repairs. Remember, a point goes x first and then y, but you have to be careful because in this equation, the y's are on the left and the x's are on the right, so you can make a silly mistake like I was almost making there. Anyway, going back to this equation, you might think that the x value is 5 and the y value is -3. You might think that those were the points that led to that equation, but I'm going to show you that that's actually wrong. If I were to take 5 and negative 3 and put it into this equation, I would get this. Y minus, and now I'd have to plug in the negative 3, equals the slope x minus, now I'd have to plug in the 5. Well, this is really like y plus 3, because minus a minus is a plus. So this is the point that I thought it was, but when I plugged it in, notice that this is not giving me what I think it should give me, which means that's a bad point, and these equations don't match up with that. That was a lot of talk to say, be very, very careful with your point. In this case, the point's actually going to be an x value of negative 5 and a y value of positive 3. I can double check this. Take this x, plug it in. X minus a negative 5 is x plus 5. Take this 3 and plug it in. Y minus 3, it matches. So the point is, when you get an equation in this form, it's going to take some thought and maybe some trial and error to see what the true point is that goes along with it. Finding the slope, not a big deal. All right, so now that I know the point, I can plot it and then plot the slope. There's the point, negative 5, 3. And the slope is going to be 2/3. So I could say a rise of 2, right 3, a rise of 2, right 3, and I can keep up that pattern. Or I could even say a rise of negative 2, which is a fall of 2, and left 3. Down 2, left 3, down 2, left 3. I could keep doing that, but notice it falls right on that line. Okay, let's do these last two problems. We're given 2 points, we don't have a graph, and we're going to find the equation that goes through there. And the first thing I would notice is that neither of these are y-intercepts. Because remember, a y-intercept always has an x value of 0. So something like 0, 3 is a y-intercept. 0, negative 8, that's a y-intercept. But these are not y-intercepts. That's a good clue to tell me I'm interested in point-slope form, because I need a slope and any point. Well, I definitely have any point. I've got these two to choose from, and I can figure out the slope. So I'm going to write out the equation of my line. I'm going to leave some space right underneath it because that's where I'm going to enter the information. And I need 2 things. I need a point, and I need a slope. Now I get to use any of these 2 points I want. I'll choose negative 6, 2. Now I need a slope, and I need to figure that slope out by doing my y minus y over x minus x. So I've went ahead and I've done my y minus y over my x minus x, and I get a slope of negative 3/5. Okay, so the point was, I looked at this, no y-intercept. So I choose a point, I figure out the slope, and that's enough information to go into here. Take some time to remind yourself that's my x value, that's my y value. So y minus 2, slope, x minus a negative 6. Okay, there's a little tricky thing. X minus a negative 6, x minus a negative 6. So a lot of times someone will take that and that minus a minus, which looks clunky, they'll turn that into a plus. And you have your final answer right there. All right, we've got one more. We have this equation. It's right now in point-slope form, but we want to convert it to slope-intercept form. And remember, slope-intercept form is y equals mx plus b. This is the most famous and probably the most useful form, so there's going to be plenty of times where you convert something else into y equals mx plus b slope-intercept form. Well, when I do that, you notice that y is by itself. So when I look at a problem like this, I'm thinking to myself, solve for y. If I can solve for y, get y by itself, I'm almost always in slope-intercept form, or I'm darn close. So I'm going to go ahead and take this equation, and I'm going to solve for y. On the left-hand side, for my first step, I'm not going to do anything special. On the right-hand side, I'm going to distribute the 2/5. 2/5 of 15 is 6. And if you're not a fan of mental math, then go to the calculator and get that done. But I take a look at this, and I do not have y equals mx plus b because y is not by itself. But if I now add 4 to each side, I get y by itself. And there we go. So this equation, point-slope form, is the same thing as this equation in slope-intercept form. They look different, but if you were to take the time to graph both of those, you would end up with the same line. All right. That is our point-slope form. Notice the differences. You can use any point for point-slope, a y-intercept for slope-intercept, but they both need a slope.